Now we are going to introduce something called firewall. So now we are going to distract all the traffic. Okay, now what is happening? Let me tell you something. This is your hub. This is your Spock. This is your VNet via on-prem. Now any VM here, it is directly reaching through the VPN gateway, and any traffic which from here, it will directly go to your on-prem like this, and from here also like this. So all the traffic is directly connected. So anyone can reach anywhere here. So from hub also to the other Spock, you can directly reach because you have a VNet peering here. We have a VPN here. Now we need to introduce firewall and we need to control all the traffic. All the traffic means from on-prem, if I wanted to go to Azure, first it should go to my firewall, then it should go to my hub or my Spock. Similarly, from Spock, if I wanted to talk to another Spock, first it should go to my firewall. From firewall, it should go to the other Spock. Or if I wanted to speak to my on-prem, first from my Spock, it should go to the firewall. From firewall, it should reach my what you say on premise. So now we are going to introduce firewall. I'm going to the firewall. I'll click on create. One thing, firewall requires public IP address as well. Okay, so first I need to create a public IP address. Okay, I'm creating a public IP address for firewall. Okay, so fw-public IP address. So I'm going to select the resource group hub central US, and I'm not going to select any redundancy. I'll simply click on OK. The IP is getting created, so let's wait. OK, IP is created. So let's go to the firewall. I'll click on create firewall. I'll select my hub VNet hub subscription, and then I'll select my resource group. I'll give the name as firewall a demo. US central US is my location. Availability zone, I'm not going to select anything. I'll keep the firewall SKU as standard. OK. We need to create a firewall policy. So I'll just give demo pol. Click OK. Virtual network name. So I'll select use existing because I already have a virtual network. I'm going to deploy it in a hub VNet, and public IP address. I just created a firewall public IP address here. Because see, if we do not create any subnet, right? You remember I created a firewall subnet. Otherwise it will throw error here. Since we already created, it did not throw any error. That's it. It's very simple. Just click review and create. So now we are going to deploy the firewall. So now the architecture will be like this. So this is my hub. This is my Spock. Spock 1. This is my Spock 2. This is my on-premise. Here I have my subnet 1, subnet 2. In this I have a VM. Here I'm going to deploy a firewall. Then the last subnet I have my gateway. The connectivity from here it is to the gateway. From here we have like this, right? So now everything what it now we are going to alter the route. OK, so we are going to say that from Spock you send everything to firewall. This is the route table we are going to create. Guys, please keep this in mind. Now there is no route table. Everything is going as per the default Microsoft routing. It means everything is going to the internet, and whatever related to the gateway, it is going to the VPN gateway. I'll show you one more thing before I create a route table. OK, so you may have a question. How my Spock is going to the on-prem use, how it will get to know that if I wanted to talk to 10.192.168.1 from here, how it will get to know that it should go to the VPN gateway? Because I told you earlier that I need to enter the route, right? So unless and until I enter the route to say that you need to go to the gateway, otherwise it won't go. So the thing is, the moment you create this VPN peering, right, and you will say one option called use remote gateway. So what it will do, it will automatically add a route to this whatever the VMs over here, right? It will automatically add a route saying that any traffic to on-prem, use that route and go to the gateway. I will show you that default route which is added. I'm going to the virtual machine now. That is a spoke one virtual machine, which is AVD VM. Guys, see this very carefully, okay? If I go to my NIC networking, this is very useful when you do the troubleshooting. And select your NIC. This is my NIC. And now go to the effective routing. See, automatically when you do the peering, right, two routes will be added. One route related to the VNets, which is hub VNet, and another route related to my gateway, which should go to the on-prem. I will show you that. Can you see this one? 10.163.0.0. This is VNet peering route. It means if I access anything related to 10.163, which is my hub, the traffic should go through the VNet peering. It means if I go to my whiteboard, let's say from here, if I wanted to try 10.163.something.com, it should go using this VNet peering route, because this is by default it is adding. And similarly, if I wanted to access anything from on-prem, it will add one more route here, right? You can see virtual network gateway. So if you try to do anything 10.196.0.0 on your SPOC, the next hop should be virtual network gateway. It means it should go to gateway, this one. If I remove this route, right? If you delete this route, then you won't be able to reach your on-premise. Okay, so this is the default routes it will add when you do VNet peering. Always remember. Now what we are going to do, we need to alter this route. We are saying that if you wanted to go to wherever, whether it is Azure or on-premise, first you need to go to my firewall. Then you go wherever you want, because I wanted to control the traffic. So see, now what is happening? Now traffic is directly going to my hub VM or directly going to my on premise through this gateway. Now I'm saying that don't go that way. You first go to the firewall. It means there is a firewall here, right? So all the traffic you should go here. From here, you may go to your hub, or you may go to your on premise, or you may go to internet. I don't care. But first you need to go to the firewall. So let's do this now. Okay. So for that, what I'm going to do, I'm adding a route table here, saying that all the traffic that is 0.0.0 should go to my firewall. Here also I'll add the same. All the traffic should go to my firewall. Here also I will add the same, that all the traffic should go to the firewall. So let's add all those route table. Let's finish S1 and S2 route table. Okay, let's see our firewall is completed. By the time we'll create a route table. Okay, we need two route table for two SPOCs. First we'll finish that. SPOC 2 Citrix RG Central US. I'll give the name SPOC to route table. Okay, you see this, okay, this is very important, very important options. So I'm going for SPOC 1, I selected yes. For SPOC 2, I'm going to select no. This is very important options. Okay, so when you select S, right, it will automatically take that default route which I shown right earlier. It won't overwrite that route. If you select yes, it won't consider your firewall. It will directly send to on-prem. But if you select no, it won't learn any routes from the on-premise, so that it will send all the traffic to your firewall itself. So okay, so spoke to I'm selecting no. It means all the traffic it will go directly to the firewall. But for spoke one, I will show what will happen if I select yes. Okay, I'll create yes. I will show you the architecture, how it works. So now you have a hub, you have a on-premise, you have spoke one, right? So you have a VPN gateway here, you have firewall here. So it is connected like this, right? So now if you select route propagation on, it means it will learn all the routes. It will learn that this interface here, the network interface over here, right? It will learn all the on-premise things over here. If you select route propagation on it, so that it will send traffic directly to this because it knows the route. But if you add the route table saying that all the traffic should go to firewall, and if you turn on that option, it will deny this, sorry, it will ignore this, and it will take this precedent and it will go to the on-premise. So always in a hub and spoke model, do not enable this one, always make off, so that it should not learn any routes and all the traffic should go to firewall. Firewall will know the routes and it will send it to on-premise. So I'll demonstrate one with the on and one with the off. Off is the behavior. Okay, I'm creating a route filter, sorry, a route table now. Okay, I'll select hub. I'll select resource group, central US, my location. I'll select name as Spock 1 we created, Spock 2 we created, right? Okay, Spock 1 we need to create, Spock 1 RT. Here I will enable yes. It means it will learn the route and it will ignore the firewall, irrespective of whatever the route I add. Okay. Perfect. My firewall is also completed. So now the architecture is like this. My hub is there. My Spock is there. Spock 1, Spock 2. My on-premise is there. My VPN gateway, which is connected like this, and I have a firewall now. And this is a VNet peering. Now what I'm going to do, I will add a route here. Route table which I already created, right? In that I'm going to add a route saying that all traffic should go to my firewall. Similarly here, I will say all traffic should go to my firewall. Let's see the magic. Here I enabled one option. Here I did not enable one option, that route propagation, and we'll see. So to do that, first we need to go to the firewall. So first you need to get the firewall IP address because I need to add the route, right? What is the destination? This is the destination. Here it should go. Now this is my Spock 2, right? So I'm going to the routes. I'll say that default I'll put. I'll say that it is IP address. Any traffic, irrespective of on-prem, internet, whatever it is, you should first go to my virtual appliance, which is nothing but my firewall. So I'm putting the firewall IP address. You guys are following, I believe. So now I will click add. So if I go to my now I created a route table, but I did not attach that route table to the subnet. Somebody asked in the beginning whether it is on a VNet level or subnet level. So it is on the subnet level. See, so now before attaching, I will see the traceroute from Spock 2. Okay, if you see the traceroute to my on-premise 10.192.160.0.4 traceroute, you won't see the firewall IP address here because I didn't. Traffic is not yet go like it did not go to the firewall yet. It is still going directly to my VPN gateway. From there, it will reach my on-premise. Okay. Sorry, it is 10.192.168.0.4. See, it is directly reaching. It is not passing through the firewall. So now I'm going to do the magic. I'll associate this subnet to Spock 2. I may lose the connection now, RDP connection. I will tell you why. See, route table always defines outgoing traffic, okay, not incoming traffic. So it will show you the route to the outgoing traffic from VM wherever it is going. So now if I go to my Citrix VM, it may take some time. See, I lost the connection as I told you, right? From the hub, I can take the remote off, my Spock because it is having a direct VNet peering. Now I will show you the tracer. Okay. And I'll also explain why my remote desktop connection got disconnected. Okay. See, now I'm going to check the tracer from Spock 1, Spock 2 to my on-prem. Earlier, it used to go directly through the VPN gateway. Now it has to pass through the firewall. Guys, can you see this? 10.163.2.7. 2.7. If I go to my Azure portal, if I go to my virtual network, and if I go to hub, and if I go to the subnet, can you see 2 dot belongs to which subnet? Azure Firewall. So now what is happening? It is directly going to the firewall. Okay. Now after that, it is not going. Why? Because in firewall, I did not define the rule. That is why it is blocking there. So now we'll go to my firewall and we'll allow the rule. So I'll put a continuous ping 192.168.0.4/t. Okay, now I'm going to my firewall. I need to go to the firewall policy here. I need to go to my network rules. I will add a rule. I will say that allow on-prem from Spock 2. Okay, so I'm going to give the priority as 120. I will name as test1. IP address. So source from where the traffic is coming. Traffic is coming from Spock 2, right? Spock 2 IP address is 10.145.0.0/24. Protocol, I'm going to allow anything. Destination port, I'm allowing all the ports. Destination type is IP address, and destination is my on-premise, which is 192.168.0.0/24. Okay. I'll click add. Now what I have done is all the traffic from Spock, it is terminating over here now. So now here I added saying that, okay, any traffic which is coming from S2, allow it to my on-premise. Okay, so now this traffic it will go to the on-premise using this VPN. So let's see the behavior. So let's wait because this will take 2 minutes for the rule update. So let's wait till it finishes the rule. By the time I'll create a route table for my Spock 1. See, it is now, it established the communication. Can you see? Earlier, it was not allowing. I will also show the tracer. It is going to the firewall. From firewall, it is directly reaching over to the VM on the on-premise using VPN gateway. So now it is passing over the firewall and it is reaching the gateway. So now you should know from the Spock, we send the traffic to the firewall using route table, and in firewall, we allowed to go to the on-premise.
Incoming traffic was disconnected. Your session was disconnected.
Yeah. Very good question. I'll tell you something, because this is my public internet where I am connected to this VM, right? Directly RDP over public IP address. You got my point? Okay, so now earlier there was no route table, everything was allowed. So now I added route table saying that all the traffic should go to firewall. It means my incoming traffic will reach till my firewall, sorry, till my VM directly because I have a public IP address. But the return traffic, it won't take this path. It will go to my firewall. You got my point?
Okay.
Because in firewall, the traffic did not come at all. This is called asymmetric routing, which is very important in your Azure network, because firewall will allow only the traffic which it is received. Now it doesn't have anything, so that is why I lost my RDP connection. It's clear, right?
Yeah, got it.
Okay. Okay. So now, guys,
So the return
now
path has changed. That's why
yes,
it is
return
not.
path is changed exactly. Now what I have to do in order to take RDP, I need to do the netting, destination netting that I'm not covering in this one. So that is a different topic. Okay. So guys, you are clear. From Spock, we diverted traffic to firewall. From firewall, we are allowing it to the on-premise. This is one way is completed. Now the second one is between the Spock. Okay. So before going to between the Spock, I will tell you I enabled one option here, right? Route propagation. I'm going to bind the same route table here also in the Spock 1, sorry, Spock 1, because so far we are looking into the Spock 2. See, route table is completed. I'm going to the routes. I'm adding the route, which is, I'll say default. I'll say IP address. I'll say anything. Now I will lost connection to this VM also. Okay. I'll say my traffic should go to my Azure Firewall. What is the Azure Firewall IP address? If I go here, I'll copy this IP address and I'll add it over here. Okay. Now I created the route table for Spock 1. And then I'm going to attach this route table to my data mistake. I created a route table in a different VNet. Spock 1, AVD, Setolius, Spock 1, RT. I'll enable this. Okay. Because this is very important. That is why, because earlier it was no. Now I'm enabled this yes. Only the small option. See what is the big change it will do. Okay. Create. Okay, done. I'm going to the route table. I will add the route. Next hop is my virtual appliance. I'll add the IP address. I'll say default. I'll say IP address. I'll say anything /0. Next. Okay. Now I will go to my Spock 1 VM where I attach this route table. Okay. See this, I lost the connection. This is because of asymmetric routing now, because now everything going to the firewall. It is assuming like that. Okay. So now I will go to my hub and I will take the remote of that. MSTSC. I think I already have the remote. Okay, now see, now it should change the path, right? I'm going to the on-prem, but see, it is still going directly. You got my point? It is not hitting the firewall. 192.168.0.4. I'm still able to ping. It is going. It is not at all hitting the firewall. Though I have the route table, I have route defined, everything should go to my firewall. Still, it is not going. Why it is not going? Because of this small change. This small change, what it will do, it will say you directly learn the route from the VPN gateway and you directly send. To verify that, I will go to my Spock VM. I'll go to my Spock 1 VM. Okay. I'll go to networking. I'll go to my interface. I will go to my effective routes. Similarly here, I'll go to my virtual machine, Spock to virtual machine, and you see the difference. That small check mark, what difference it will make. Okay, here I will go effective routes. See here, because of that small check mark, right? Still the earlier learned route is still there. It is saying that anything to on-prem you directly go. You do not consider any route table. It will ignore the route table. If you go to the spoke 2, you don't see any other routes. See, all the routes disappeared. Everything is going to my firewall. In a production environment, you have to enable, so you have to disable that option so that all the traffic it should go to virtual appliance. From there it should go to. So if you do not do that, again it will bypass the firewall and it will directly exit from the VPN and it will reach. Okay, this is only for the on-premise traffic, not for the Azure one. Okay, if you ping, if you trace it, my Azure, that is 10.145.0.0.4. Let's see what is the response. Okay, it is not, it is getting timed out. I'll tell you something. Now you guys are very well aware that how Spock to on-prem through firewall working and how Spock to on-prem when you disable that route propagation is working. Okay, now what I'm going to do, I will enable that route propagation. Spock 1, I'll go here. I'll go to the configuration. I'll say no. I'll click yes. Okay, so now it is saved. I'll go to the VM. Earlier you can see there is n number of routes, so you can see right now you don't see all those routes because we disabled. So I'll go to the Spock 1. Networking. Okay, effective routes. Just see now everything will disappear. Only it will have the firewall details similar to this VM because we told that you should not. Okay, it may take some time that we can verify over here. Okay, 10.125. Okay, reset. That will take some time. That is why it is. Let's do one thing. So now coming to one of the questions asked, how we enable this one, right? So, spoke 1 to spoke 2. Now we need to, now we covered how to communicate from on-prem to Azure through firewall. Sorry, from Azure to on-prem through firewall and from hub from spoke. Now spoke to spoke communication, how we can do. So now all the traffic will from the spoke 1, it will terminate in firewall 1. So now we will allow this rule in the firewall. Okay, I'm going to the firewall. I'm going to the rule. Rule collection. Okay, network rules. Okay, I will click on new rule. Allow spokes. Okay, I'll select 140. I'll select network rule. I'll select allow spoke. I'll say from source. What is my source? Spoke 1 source 10.125.0.0/24, right? Protocol everything. Destination, all the source, destination IP address. The destination is another spoke, which is 10.145.0.0/24. This is from spoke 1 to spoke 2. Now we need to define spoke 2 to 1, right? Spoke 2. Similarly, define here 10.145.0.0/24. Select any star, put spoke 1 IP address 10.125.0.0/24. The moment you add this, okay, so you should be able to communicate between the spokes. Now, if I go to my spoke, this is my SPOC 1, right? Ping. To avoid confusion, first check what is the IP address. This is SPOC 1. Ping 10.145.0.0, sorry, 0.4 -t. So I put a continuous ping. So similarly, I will go to my SPOC 2. ipconfig ping 10.125.0.4 -t. So it is still creating the rule. The moment it creates the rule, you are able to communicate between the SPOC also through the firewall. So now what we have covered, we covered traffic from SPOC to on-prem over the firewall. This let's draw it another way. This is my hub. This is my firewall. This is my VPN. SPOC 1, SPOC 2, by on-premise. Now we can communicate to on-prem through the firewall. From SPOC also we can communicate through the firewall. Between SPOC also we can do through the firewall. Now tell me one more thing is pending. Can you tell me what is that pending? One more communication which is not going through the firewall. Can you tell me? So can somebody tell me which traffic is now not going through the firewall?
On-prem.
Exactly. Now if you try to access from here to SPOC, right, it is directly going. Okay, now we need to alter this. We need to say that any traffic from on-prem, it should go to my firewall. Then from firewall, it should go to my SPOC or SPOC 2. If you complete this, we are done with the landing zone. Sorry, done with the hub and SPOC model. Okay, so let's do this. Before that, we will verify this SPOC 2 communication because its rule is already in progress. We'll see what is the rule is completed. Okay, 10.125.0.0 is not talking to this one. Okay, we'll see what is the problem. We said that anything from SPOC 1 to SPOC, this one should be allowed. Any traffic should be allowed. This looks fine. And let's go to my virtual network. Should work immediately. Let's see. Okay, it is still not that gateway propagation I told you, right? So it is not still not taking effect. So let's see what is the SPOC 1 we have here. We have a subnet. See, I did not associate. That is why. Okay, ABD subnet. So now I'm substitute. Now I'm adding the route here. Sorry, route table attaching to my subnet 1. Okay. The moment it is finished attaching, then we should be able to see traffic between the SPOCs. About 125 dot. Okay, let's see what is wrong. So let's see. Propagation is no. Everything is going to the 162.4. Okay. This is also fine. Here also fine. It is going to the 0.4. Firewall. Let's see firewall. This is 10.
Is it a 24 or 25? Because you mentioned the subnet value is different, right?
Where? Just
145 dot all are 24.
Yeah, it's 24.
But maybe it's because of the rule. Both are 140. I think it has to be unique or something.
No. So it has to be. It should be fine. So let's see. Let's see. It is still able to communicate or not. Yeah. See, it just took a time. Got my point. So now I'm able to. Yeah. Because it sometimes it may take some time. So my from spoke 2 to spoke 1 I'm able to communicate because of this rule. Because of this rule. Because I'm saying some spoke, that is source 1 is spoke 2 to destination spoke 1, it should communicate. Now using this rule I will communicate from spoke 1 to spoke 2. Okay, so I'm going to the VM which is my spoke 1 VM and I will ping to spoke 2. It is working, and if I go to the other way which is my spoke 2 and if I ping to spoke 1, it should also working. So now we completed all the use case. Now very important use case is how we can restrict the on-premise traffic. For example, now this is spoke, this is my on-prem. This communication is fine, this communication is fine, everything is coming to the firewall and talking and going. From here also it is going to the firewall and then VPN gateway, it is going. From here also it is going like this. But if I try something from my VM here, right, to my VDI or over here, it directly it is going now. As of now it is not going through the firewall. I'll show you by showing you the tracer. I'm in the on-premise network. Okay, I'll check the IP address. This is my IP address of on-premise. I'm going to ping one of the SPOC, that is 10.125.0.4. Reset, sorry. You may see it is not going through the firewall. It will directly go. See, it is not going through the firewall. It is directly, it will go and it will reach my VM. Now it is not, now it won't ping. Why? Because 10.125.0.4. If I ping, can you someone tell me why it is stopped pinging?
Same asymmetric.
Exactly, it is asymmetric routing. It means my VM from here, the traffic is reaching till this VM. But the return path, I have the default route, right? It is sending back to my firewall. So firewall is dropping. Why? Because it did not receive the traffic at all. So this is called asymmetric routing and it is dropping the packets. Now what magic we have to do? We have something called gateway subnet here, right? You remember I created a gateway subnet.
Yes, gateway subnet.
Yeah, now I will create a route table to this gateway subnet. I will say whatever the traffic which is coming to this gateway, first it should go to my firewall. So when I apply this route table to this subnet, irrespective of any traffic coming from on-premise, first it will go to the VPN gateway. VPN gateway, now it will send it to firewall. Earlier it used to send directly to my spokes. Perfect.
Yes.
Now,
can you repeat that?
Yes, definitely I'll repeat. Now, see, now this is my hub. This is my SPOC. SPOC 1, SPOC 2. This is my on-prem. I have a firewall here. I have a VPN. Now what is happening? You know all the traffic from Azure to on-prem, right? Everything is you understood. Now, whatever, let's say you are trying to access your VDI, which is in SPOC 1, what will happen? It will directly go to the VPN. So VPN, it will directly send it to my SPOC. Similarly here. Now we need to force this traffic. Instead of directly sending all the traffic, it should go to my firewall. Okay, to do that, what I'm going to do, I'll create a route table. Okay, I will say any traffic which is going to my SPOC, which is S1 or S2 or any traffic 0.0.0.0. Okay, first it should go to my firewall. I'll add that rule and I'll bind this route table to a gateway subnet. There is a gateway subnet I created. You remember?
Yes.
Yes, yes, yes.
Yes. When I bind this, right, irrespective of any traffic which is receiving from on-prem, first it will send it to firewall. Firewall will check and it will allow it. Okay, let's do that.
Yes. Okay. Got it.
Okay, so now what I'm going to do, I'll create a route table first. I will name a route table as gateway route table. Okay, I'll put hub. I will put hub central. I'll say gateway route table. Here you need to always enable S because your gateway should learn all the routes. Okay, never ever do no in the hub route table. Okay, for always for the gateway subnet you have to enable yes because your gateway should learn the route. I'll simply click yes. For the Spock, never ever select yes. Only for the hub route table you need to select yes. Okay, always keep these two things in mind. Because if you select no in the gateway route table, it won't be able to understand the on-premise things. Okay. Okay, I enabled route table. Now I'm going to add a route saying that for any Spock, the traffic is coming from on-premise, it should go to my firewall first. Okay. Okay, my route table is ready.
Yeah, thanks.
So now, now my route table is ready. I'm going to attach this route table to my gateway subnet. For to do that, I'll go to my virtual network. I will select my hub VNet. I'll go to my subnet. You can see gateway subnet, right? I'll select gateway subnet. Route table, I'll select gateway route table. Okay. Yeah, Spock 1. I'm saying that IP address 10.125.0.0/24. It should go to my firewall. Okay, because on-prem will carry this traffic as a destination. So now we need to say that to go to this destination, you need to go first to my firewall. Okay. Let me pull the IP address. I'll go to my, okay. See, now the source is on-prem, destination is my Spock 1. In between you are bringing firewall. So for firewall, the destination is 10.125.0.0. Now it should work as per my understanding. So let's see. Let's give it some time. I'll add one more also. Okay, so now from my on-prem, I should be able to reach both, which is my yeah, let's see. It is still taking this path. Okay, perfect. Can you see something in the trace search result? I'm trying to access from on-prem to Spock 1. First, it is going to the VPN gateway. Okay. Then it is going to my
Firewall.
firewall. Exactly. After that, it is not going. Can you tell me why? In the firewall, I did not define the
We
rule
don't
to
have
allow
rule.
from,
Yeah,
yeah,
to allow rules.
from,
Rule
yes,
define.
exactly. So now I'm going to my firewall. I'll go to my firewall. I will say that I'll create one rule, network rule. I'll edit just to show that you can edit this also. I'm going to edit and I'll add it here. I'll say that anything coming from 192.168.0.0/24 to 145 as well as 10.125.0.0/24. Okay, and again I'm going to add one more rule, 10.145.0.0/24, which is going to my VPN, which is 192.168.0.0/24. So both should have a similar. You got it. You got this rule. What I defined? I defined from spoke it should go to on-prem. From on-prem it should go to both the spokes. You can see both the IPs right here. 3 IPs. One is spoke 1, spoke 2 on-prem, and then spoke 1, spoke 2 on-prem. Is it clear? The rule is clear?
Yes.
Yes.
Okay. Now, if I come to my diagram, so we have a hub, we have Spock, we have my on-prem. It is VNet paired, it is VPN connected, we have a firewall. Now the traffic from on-premise, it will go to my VPN. From VPN, it will go to my Azure Firewall. From Firewall, it will go to my Spock. From here also, it will go to the Spock 2. Okay, Spock 1, Spock 2. Similarly, from here also, it will flow in the same way. All the traffic will go to the firewall. From firewall, it will go to on-premise, which we already, discussed and we have seen that. So if we complete this one, then yeah, today's topic is completed. And let's see. I'm in on-premise and I'm just waiting this to allow. Perfect. See, I'm able to go to from on-prem. I can able to go to my firewall. From firewall, I'm able to go to my Spock. Now our traffic is completely secured. Completely, I cannot say completely secured. No, completely centralizedly managed. Okay, so everything is coming and terminating in the firewall. From firewall, it is going to my Spock hub or whatever it is. Okay, so this is the, see, the traceroute is also completed. So if I do the traceroute for my 10.145, same way. Okay, same way it will go.